Hi, algebra students, college algebra students. So today we're going to be looking at lesson 3.1. It's all about graphing lines in the coordinate plane. You're also going to be learning about the midpoint and distance formula, and we'll talk about special cases of lines that you'll be plotting. But first to start, we want to start by reviewing graphing ordered pairs. So the first thing is you have the rectangular coordinate system or the Cartesian coordinate system. And that's got your horizontal line, your x-axis and your y-axis. And we've got the center called the origin. And these lines split this into 4 quadrants. First quadrant is up on the top, right, and that's where all the positive coordinates are. And then you've got the second quadrant over here, third quadrant down here, fourth quadrant here. So it kind of forms a C. So you can think of like that. It starts up at the top right and then it forms a little C. 1, 2, 3, 4. Okay, so when you're plotting or graphing points, you want to remember that we've got an x coordinate and a y coordinate. The x coordinate tells you to go left or right. And you're going to want to start on the center, on the origin, and then you're going to want to use the x value to tell you to go in the positive direction, right, or in the negative direction, like in this case, which will be going left. So always start by going left or right first. Then you can go up or down using the y coordinate. So these are all, like I said, x coordinates, then y's. X, y, x, y, okay? So let's start plotting some of these. So if we plot this first one, let's call this one A, and we can call this B, C, D, E, and F. I'm just going to label them like that so it's a little bit easier for me instead of actually having to write out the numbers on the graph. So if we plot this first one, again, start in the middle, and then you're going to go right 2, that's what that says, right 2, and then you're going to go up 4. So 1, 2, 3, 4. You put your little point, and I'm going to title that A. So that's how I do the first one. B, 4, 2. That means right 4, up 2. So we're going to start in the center, go right 1, 2, 3, 4, go up 2. So there's B. Notice these are both in the first quadrant. Okay, then we have C. This is saying go from the center, go left 2 and down 3. Okay, so this negative is telling us direction really, but yeah, it's saying to go left 2, and then positive would be up, but this is negative, so you're going to go down 3. So that's point C. Point D is left 1, up 3. We go left and up. So far we've got C in our third quadrant, D in our second quadrant. This one, 0, 4, that means don't go left or right. So you start in the middle, you don't go left or right, you just go up 4. So this is going to be right on the y-axis. So up 1, 2, 3, 4. It's right on the y-axis, and that's point E. Okay? So it's not in a quadrant, it's on the axis. And then point F is 4, negative 2. So that tells us to go right, 1, 2, 3, 4, and down 2. So that's the only one now that's in the fourth quadrant. So again, just remember, start with X, go left or right, then go up or down next, okay? The next thing they want to talk about, which you saw in your pre-assessment, was the midpoint and distance formulas. The midpoint just means find the halfway point that's between your two endpoints. And then the distance formula is finding the length of the line segment. So if they say find the midpoint and length of the line segment, they're asking you again to find the midpoint, and they're also asking you to find the length of the line segment. So I've got our formulas written right over here for you, and we are using the midpoint formula right here. The midpoint is a point, so don't forget when you write your midpoint, you want to write it as a point. This is going to be the x value, the first number that you get, and this is going to be the y value, okay? So what you want to do is look at the formula here and say, okay, this is x1 plus x2. So that means we've got two x values and two y values, okay? Let's call this x1, y1, and this next point will be x2, y2. Okay, so you are going to be adding the two x values together and dividing by 2. That's the same thing as averaging them, okay, finding the midpoint, finding the middle. So for our midpoint, we can say, and I'll just show you part of this, for our work, we can show we're doing 1 plus 5, that's x1 plus x2. 1 plus 5 over 2, okay? So we're going to add those two values together and divide by 2. I'll put a comma there. And then we're going to do the same thing with the y's. Notice in the formula, it's y1 plus y2 over 2. So we look here and we say, okay, that's 7 plus 4 over 2. And then just simplify this, okay? So 1 plus 5 is 6. 6 divided by 2 is 3. And then we put our comma. And then 7 plus 4 is 11. And you can't, that's not, it's odd. So we're just going to leave this as 11 over 2. Okay? So that's the final answer for your midpoint. Again, it's a point. So don't write just one number. So we found the midpoint, and now we want to find the length of the line segment, or the distance between the 2 points, okay? So if we do that, this is kind of like Pythagorean theorem. It's almost identical to it, but it's just written in a different way, because if you think about, I'll actually show you on here. Let's plot 1, 7, and 5, 4. So if I were to plot 1, 7, so I'd go 1 over to the right 1 and up 1, 2, 3, 4, 5, 6, 7. So 1, 7 is here, and then 5, 4. So that's 1, 2, 3, 4, 5, and up 1, 2, 3, 4. So I'm looking for this length. I'm looking for that distance, okay? And all of the distance formula is doing is it's saying find the difference between the two x values. So find the length of this triangle that's formed. We're going to find the length of this segment of the triangle that's formed with the x values, basically. Find the length, find the distance between the x values. So here's this x2 minus x1 right here, because you're looking at the difference in the two x values, okay? The difference in the two x values here is 4 units. Okay, you can kind of see that 1, 2, 3, 4. And then you're asked to find the difference in the y values, and that's 3 units. And then from here you could think, okay, if I want to find the hypotenuse, I'm just going to say a squared plus b squared equals c squared. And just remember, when you find, when you use that Pythagorean theorem, like where this is a and this is b, remember, in order to get c, you have to take the square root. So that's all this distance formula is doing. This is a visual way of looking at it. Okay, so just remember that, 3 and 4. This is the formula way that we're going to do it. Okay, so if we look at it in a formula way, we'll do x2 minus x1. So that's going to be 5 minus 1. So 5 minus 1, and you would square it. And then that would represent like a squared. And then this is the y2 minus y1. So 4 minus 7. And don't forget to put the plus sign. So plus 4 minus 7 squared. And that's like your b squared. I know this looks like it's going to be a negative, but remember, if you square a negative, you get a positive. So you'll see when we simplify this, we're going to get 5 minus 1, which is 4, and that's 4 squared. And again, that's the number we had back here on our picture right here. That's the difference between the two x values. And then here we get 4 minus 7 is negative 3, but we're going to square it. So we'll end up getting the same value as if we squared a positive 3, okay? So now 4 squared is 16, and 3 squared, negative 3 squared, is 9, because negative 3 times negative 3 is positive 9. And so then we end up getting 25 when we simplify this underneath the square root. And then the square root of 25 is 5. So the length of our line segment is 5. And if you were to go back over here, again, a Pythagorean triple, one of the most popular ones that they have on the SAT, is 3, 4, 5. So if you memorize that, 3, 4, 5, that might help you with a lot of different problems on the SAT, but that is how you do that. The next thing that you're asked to do is graph an equation, graph a line. So I'll bring this back over here. So on this example 3, it says to graph y equals 2x plus 3. Now, you only really need 2 points to form a line. They might ask you for 4. I am definitely going to require 3. 3 just makes a nice line, and that's the only reason I want you to do 3 points. But if it just says to graph it, then just pick 3 points. If it says plot at least 4, then just follow the directions. So if you're going to plot a point, or a line, the one way to do this is to make an X and Y chart, and you could plug in, the most common numbers to plug in when you're graphing a line is a -1, a 0, and a 1 for the X values. These are called your independent variables. They're the ones that we're going to pick, and then when we plug them in, the y's will depend on the x's we chose. So the y's are called the dependent variable. So again, what we're going to do is plug in each one of these and get a y value, a corresponding y value, and then we're going to plot it. So if we plug in a -1, that would be 2 times -1. 2 times -1 is -2. -2 plus 3, okay, and if you want to write part of that, -2 plus 3 over here, you can say that's equal to 1. So our first point is -1, 1, okay? So that's going to be here, -1, 1. So we'll just plot that, okay? Now we'll plug in a 0. 2 times 0 is 0. 0 plus 3 is 3. So I can say 0, 3. That means I don't go left or right. I go straight up. 1, 2, 3. So now I have that one. Technically, I have enough to form a line. It's just 2 points to form a line, but I'll do one more. So for this one, plugging in a 1, that's 2 times 1, that's 2. 2 plus 3, and again, if you want to write that, I didn't write the one with the 0, but 2 plus 3 is 5. So you have 1, 5. So 1, go to the right 1, and up 5. Okay? And I'm going to use a straight edge here and try to get a nice line. Okay? So you're going to want to maybe use a straight edge. You could even use, your notebook or something flat that, you can make a nice line with. Don't forget to put your arrows at the end because it is a line, so you want to imply that it goes on in both directions. So again, that's all you need for that one. Another way we could have plotted this was using the slope-intercept method, okay? And the slope-intercept method, just recall, is looking at this value here and this here. This is the y-intercept, and this is the slope. If you remember, y equals mx plus b, b is your y-intercept. So you could start at 3, meaning on the y-axis, locate positive 3. So that would be right here. And look, we already got a point right there. Then from there, you can use your slope 2 or 2 over 1 to get your next point. So that would mean if you use 2 over 1, since our slope, I'll just write this, slope is 2 over 1, and the y-intercept is 0, 3. If we use the slope of 2 over 1, we're going to start at our y-intercept. So after we've plotted the y-intercept, we then can go up to right 1. And we'll cover this in the next lesson, but you would go up to and right 1 and plot your point, okay? So that's another way to graph, but for this particular lesson, they're wanting you to find 3 points at least. So another example, here's example 4. So I'll move this up, and hopefully you can see that there. So example 4. So it says, it's my dog barking in the background, graph y equals 2x, actually this is y plus 2x equals 1. And then it says plot at least 4 points. So again, you could do your x and y chart, and you can find values that will work. Because they said 4 points, what you could do is do the ones we already did, the -1, 0, 1, and then maybe just do a 2. You could also do -2, -1, 0, and 1. So again, you could do that. What might make it easier on us is if we solve for y. So I'm just going to subtract the 2x to the other side, and that's going to make that y equals, when I move this over to the other side, it changes signs. So I can say minus 2x plus 1. So if I do it like that, then I can, again, plug the values in, get the points, plot the line. So if I do it, -1 times -2 is positive 2. Again, I'm plugging in the x value. Positive 2 plus 1 is 3. Let's just keep going, I guess. 0 times -2 is 0. 0 plus 1 is 1. And then we've got 1 times -2. That's -2. -2 plus 1 is -1. And lastly, -2 times 2 is -4. -4 plus 1 is -3. And now we're going to plot these. So we've got -1, 3. So we go left 1, up 3. Not going left or right. We start in the middle. We don't go left or right. We just go up 1. Okay? So that goes there. Then we have 1, -1. So that means go right 1, down 1. And lastly, right 2, down 3. And again, use a straight edge of some kind. It can be a note card or something like that. Just make a nice line, and don't forget to put the arrows at the end. So that's how you do examples 1 through 4. Example 5. I'm going to flip this over here. Example 5 is graphing horizontal lines. So they ask you to plot y equals 2. This means no matter what x is, y will equal 2 every time, okay? So it's independent of the x value, okay? So if I were to show you some values here, again, you just have 2 no matter what. Y just equals 2 every time. So we can say -1, 0, and 1 for the x values, but y will equal 2. which means it's going to be a horizontal line. The y ones are horizontal lines. So we say -1, 2, 0, 2. Oh, these are numbered. That's nice. 0, 2, and 1, 2. And notice it just forms this straight line, horizontal line here at y equals 2. Draw little arrows and you're done. The same can be said for example 6. You're plotting a vertical line. Okay, so here's example 6. Example 6 is plot x equals 4. So for that, no matter what the y value is, x is equal to 4. Okay? So these are special cases for the lines. So for this one, again, we can really pick anything, but I mean, if you want to just pick your typical -1, 0, and 1, you can do that. You could spread it out more if you want. You'll see when we do this, this means go right 4, down 1, so that's going to be here. This is just right 4, don't go down. Okay, so that's here. And then this one's right 4, up 1, so that's going to be here. And notice again, it's just a straight up and down line here. So I'll try to get this as best as I can. There we go. And again, don't forget your arrows. The final thing that they want to show you is you could graph a line using intercepts. And so I'll show you that, and then we'll be done with this particular lesson. So example 7, it says use intercepts to graph 3x minus 4y equals 6. So what you need to do here is you're going to actually, in order to think about intercepts, recall that when you're on the y-axis or the x-axis, one of the values, either x or y, is equal to 0. So for a y-intercept, and I'll just write it over here, for a y-intercept, if you're on the y-axis, your x value is 0. You don't go right or left, you just go up or down. So that means it's 0, b. And you remember that from the y equals mx plus b. For the x-intercept, the y value is 0. Kind of like we plotted back up here, we did 4, 0, and that was just right on the x-axis. So that's the x-intercept, and we can call that A for the x-intercept, and then we'll say 0 for y. So what you can do then, if you look over here, you can actually plug in a 0 for either x or y and find your x or y intercepts. So let's say we're finding the x-intercept to start. That means we're going to plug in a 0 for y, okay? So if I plug in a 0 for y, I'm going to say that that's 3x minus 4 times 0 equals 6. And notice 4 times 0 is 0, so then you're just going to get 3x equals 6. And then the final step is divide both sides by 3, and x equals 2, which means 2, 0 is our x-intercept. So we would just come over here, start from the middle, go over 2, put a dot. And now we can do the same thing and get the y-intercept. And again, like I said before, you only need 2 points to form a line. So that's why you can do this. So the other way, if we're finding our y-intercept, is to plug in an x equals 0. Okay? So that would mean I'll plug in an x. I'm going to go over here and try to write that. So for the y-intercept, I'm going to put a 0 in for the x value. So I'm going to say 3 times 0 minus 4y equals 6. And then solve from here. So I have negative 4y equals 6, because that's going to go away. And then I divide both sides by negative 4. And I can reduce this. It's going to be a negative, right? If I divide the top and the bottom by 2, I get 3 over 2. So this is negative 3/2, or negative 1 1/2. So we have, again, 0 for the x, and then we have negative 3/2 for the y. So this would mean you'll want to start at the middle. Don't go up or left or right. You just want to go down 1 1/2. Okay, but I'm going to do it over here. Sorry. So start over here and then go down 1 1/2. So there's about 1 1/2. And then now we have 2 points and we can, graph our line. So we'll just do that and we're done. Next lesson is going to be about slope, the slope of a line. So for the slope of a line, so this is lesson 3.2, okay, you are going to do slope, which is rise over run, okay, so slope, or M, okay, it's rise over run. Another notation that you might have seen in science class is it's the change in y over the change in x. Okay, so you could say change in y over the change in x. And sometimes they use delta y and delta x. They do that little triangle. So this is like a science notation, delta y over delta x. And then the very final thing is a formula. So change in y means if you've got 2 points, find the difference in the y values. That's going to be on the top. That's the change in y over the change in the x values, or x2 minus x1. So that's using coordinates to find a slope. So there's some different things we can do here. One thing is we can find the slope from a graph by thinking about what's the rise over the run. We can also use the coordinates to find our slope. So we'll just do a couple of things here, and then we should be done. So for our slope, finding the slope from a graph. So I'm going to get another graph out, okay? And actually, I'll turn it over so it's got the it's got this on here. So they give us, for example A, I'll probably just do one of these examples. So for example A, they have a point here and a point here. And they say, find the slope of this line. So this is example 1A. So if we're thinking about it as rise over run, okay, what I normally do is I look from left to right. Okay, one of the things I think of is if I look left to right, if I was skiing on this, I'm going downhill, okay? I'd be falling down this hill. So I know that this is a negative slope. So if I think about rise over run, if I think about the change in the y value, it looks like it's going down 3 and then right 2. So again, it's like a fall and then you're going over. So we have, so the slope, again, thinking of rise over run, the rise means the change in the y value, and it can be negative. Okay, so we're saying that it's going down. If you look from one point to the next, it's going down 3 and right 2. So that's down 3, and that's how you represent that, negative 3. And then right 2, if you think about it, we're going toward the positives, so that's why it's a positive 2. We're going right. So that's how you would do that. If you had I guess they have another one where it's, I'll actually write this one in. So this is, that's A. And then I'll just do one more line on here because it doesn't really intersect too much with it. But this is 6, 3. So let's look at this line right here. Okay, so if we look at this line, this is B. If we look from this point to this point, we have to think rise over run. So in order to get from here to here, I could go up, okay, up 2. So my slope would be 2, up 2, and over to the right, that's also positive, 1, 2, 3, 4. So up 2, right 4, to go from left to right, from one point to the other. And then when you simplify that, that's just 1/2. 2 out of 4 is 1/2. So that's one thing. Again, they might give you the coordinates and ask you to find the slope from the coordinates. And then example 3, I'll show you there's slopes of vertical and horizontal lines. So here's example on here. This is example 2. So example 2 is find the slope of each line. So let's just do one of these. So here's A. So find the slope of 2, 5 and 6, 3. So if you're doing 2, 5 and 6, 3, if you're finding the slope of that, remember it's going to be y2 minus y1 over x2 minus x1. Okay? So if you're doing that, again, remember xy. If you think of this as, and it doesn't matter which one you choose to be x1, y1, x2, y2, you could have them reversed, but just be consistent. So normally I tell my students to write, what they're choosing as x1, y1 and x2, y2. That might help you. So again, just remember it's going to be y2 minus y1. So this is 3 minus 5. 3 minus 5 over 6, that's x2, 6 minus 2. And then you'll get negative 2 and 4 on the bottom. And then when you simplify that, it's negative 1/2. Okay? So just plug in your x1 and y1 and your x2 and y2, and don't forget y's are on top. Okay, it's the change in y over the change in x. And be consistent. If you start with, y2, this is your y2, and you're going from here over to here, make sure when you do the x's, you start in the same spot to the right. You start here and go over to here. Okay? Example 3. Actually, I'll do it on here. So example 3. Example 3 is finding the slopes for horizontal and vertical lines. So if you have a horizontal line, okay, it has a 0 slope. And I think, yeah, they show you this line here. They show you a line. It's y equals 2, basically, okay? That's just saying that everywhere y equals 2. So they just say, find the slope of that line. Well, if you think about it, we don't have a rise. We only have a run. So if you think about the term, rise over run being the slope, you've got 0 rise over, some number, okay, some number for the run. 0 divided by anything is 0. So that is why the slope of a horizontal line is 0. All right, let's go to example 3. So this was A. Here's example 3B. So if we do example 3B, they show us this vertical line. And and this vertical line is x equals 1. Okay? So for x equals 1, you only have rise. If you think about like from one point to another, you would only have rise. You don't have run. So this is like some number for the slope. Again, thinking of rise over run, it's like some number over 0. Now, can we divide by 0? No. This is undefined. You're not allowed to divide by 0, okay, in math. So this slope is called undefined, all right? The final thing I think that they talk about is parallel lines and perpendicular lines. So example 4, parallel lines. It says line L goes through the origin and is parallel to the line through -2, 3, and 4, -5. Find the slope of the line. So, going back over to here, we're going to do example 4. And then we'll talk about, we'll do example 5, and then we'll just talk about example 6, and then that should be good. So, like I said, example 4. So on example 4, again, they say parallel lines. Parallel means it has the same slope. Okay, so parallel is same slope. Okay, for perpendicular, it's the negative reciprocal slope. You probably remember that. So perpendicular lines have negative reciprocal slopes. Okay, so we're going to just use that idea when we do examples 4 and 5. So they give us 2 points. They say -2, 3, and 4, -5. So if we're trying to find the slope of the line that's parallel to this one, first we need to find the slope of that. Okay, we need to find the slope of the line that's formed with these 2 points. So we have to do y2 minus y1. So again, I'll do x1, y1, x2, y2, and then for my slope, I always do y2 minus y1. So I'm going to do -5 minus 3. And because I started over here, I'm going to start over here for the x's. I do 4 minus -2. Okay? And I'll simplify this. So this is -8 on the top. And on the bottom, this is 4 plus 2, which is 6. And then when I simplify this, it's -4 over 3. If I divide both sides, or top and the bottom by 2. So notice on this one, they wanted the line that is parallel to this. So because they want the parallel line, we're going to say this is our answer. It would be the same slope, okay? Whereas if we did example 5, okay, they're going to ask for the perpendicular. So they'll say in example 5, line L contains the point 1,6 and is perpendicular to the line through -4, 1 and 3, -2. Find the slope of line L. So it does say it contains the 0.16, but that's just extra information. All they want is the slope of the line that goes through -4, 1 and 3, -2. So that was nice of them. They gave us some extra information in there. If you wanted to actually find the equation of the line, you would use that 0.16, but again, they didn't ask for that. So that'll be the next lesson. So we're going to find the slope of the line that goes through these 2 points, and then we are going to then think, what's the perpendicular slope? What's the negative reciprocal slope? So here's the slope. So we do, again, I'll do x1, y1, x2, y2. -2 minus 1 over 3 minus negative 4. Okay, and that's going to be negative 3 over, that's 3 plus 4, which is 7. So this is the slope of the line that goes through, and we want the negative reciprocal slope. So we are going to have to flip it over and change the sign. So our perpendicular slope, and that's the sign I use for that, it's like a little corner, perpendicular slope will be 7 over 3, okay? If you wanted to write some notation that's similar to that, you could, I think, show like parallel slope, but some people don't like that notation, but you could technically do parallel slope and then just rewrite it, you know, that it's the same. But this is the one that's helpful, I think, for the perpendicular. So the very last part is just example 6, and I'll just talk about it. Using slope with geometric figures. This is just good for, you know, it's kind of incorporating geometry into the college algebra book. And so it gives you 4 points, and it says determine whether they're vertices of a rectangle. So what you could do in your book, and I'll just try to show you in your book what this looks like. Okay, so in your book, they give you these 4 points, and again they say determine whether they're vertices of a rectangle. What you would want to do is see if the opposite sides have the same slope. So you'd want to do that. So you could say, you know, you could test AD, test the slope for AD, and this is BC. You could see if those have the same slope and see if these have the same slope. So that's what they're doing here. They're just saying the slope of AB, and then this is the slope of CD. So those two should be the same slope, and notice they are. And then over here, they did the same thing for the opposite two sides. So then they said, because the opposite sides have the same slope, they're parallel. And the figure's a parallelogram. Okay, so you can tell it's a parallelogram. And then you could check that the slopes were negative reciprocals of each other, the ones that meet at a corner. See if they're negative reciprocals of each other. And that'll tell you that that's a right angle, that they're perpendicular lines. And therefore, they make a right angle, which means you have, you know, 4 right angles in here. And so you'll have a rectangle. So that's kind of an interesting thing that they do. Hope this was helpful. Check RunWeb for facts for your assignments. And for Ticket Out the Doors, maybe I'll just assign, I'll be able to assign the teacher that's in there. I'll tell you which ones to do for Ticket Out the Doors, okay?